You know, our sun isn't just a steady ball of light in the sky. It's this dynamic, churning star, and its activity rises and falls in a pretty regular 11-year cycle. For decades, scientists have gotten pretty good at predicting how intense these cycles will be. But what if the official forecast for the cycle we're in right now was missing a huge piece of the puzzle? Well, it turns out a totally new way of seeing the data might have just found it.
And that's really the big question we're diving into here. See, there's an official panel of experts, and they made their prediction for our current solar cycle 25. But then another team came along, looked at the exact same data in a completely new way, and came to a radically different conclusion.
So on one side, you have the official, kinda conservative forecast. And on the other, you have this bold new prediction for a much stronger solar cycle. So how did two groups looking at the same solar history end up with such different ideas about the future? To figure that out, we've got to follow the clues. It's a bit of a detective story.
Okay, so why do we even care? I mean, a few more sunspots, what's the big deal, right? Well, it turns out that accurately predicting the sun's fury is actually one of the most critical challenges in what we call space weather.
It all comes down to this, the solar cycle. It's the natural rhythm of the sun's magnetic field. And at its peak, what's known as a solar maximum, the sun gets incredibly active.
And a strong solar maximum isn't just a pretty light show in the sky. Nope, it means more solar flares, these huge eruptions of solar material called coronal mass ejections that can slam into Earth. These things can potentially disrupt our power grids, they can fry the satellites we rely on for GPS and all our communications, and they even pose a real danger to astronauts in space. So yeah, getting the forecast right isn't just some academic exercise, it's absolutely vital for protecting our modern world.
Now, the researchers behind this wild new forecast didn't find new data. That's the amazing part. They found a new way of seeing the old data. Instead of just looking at numbers on a simple timeline, they decided to look at it as an interconnected network.
They used this incredible technique called the visibility graph method. Okay, stick with me here. Imagine your data, say the daily sunspot number, is a mountain range. Now stand on one peak. Can you see another peak in the distance? If your line of sight isn't blocked by any taller mountains in between, you draw a line connecting them. You do this for every single peak, and suddenly your simple line graph transforms into this complex, interconnected web.
But here's the twist in the story. When the scientists first tried this standard method on the sunspot data, it got them absolutely nowhere. The network it created just didn't show any clear pattern, no correlation with the solar cycle strength. It was a total dead end. So they didn't give up. They tried a subtle but totally brilliant modification. It's called the horizontal visibility graph. The rule changed just slightly. Now you can only connect two of your mountain peaks if you can draw a perfectly straight, flat, horizontal line between them with no taller peaks getting in the way. It sounds like such a tiny change, but believe me, it made all the difference.
And that was the key. This small tweak to how they looked at the problem suddenly unlocked a hidden signal that had been buried deep inside the sun's data for decades, just waiting to be found. Now, the paper describes what they found as a clear anti-correlation. I know that sounds super technical, but the idea is fascinating. They looked at a property of the network they built. You can think of it as the network's connectedness. But they looked at it during the sun's quietest phase, the solar minimum. And what they discovered was this completely unexpected but incredibly powerful relationship.
This was the big aha moment. It turns out a weaker, less connected network signal during the sun's quiet period was a dead-on predictor of a much stronger, more chaotic solar maximum to come. It's totally counterintuitive, right? But the pattern was undeniable. The quieter the network looked when the sun was calm, the louder the sun was about to shout at its peak.
So, armed with this new key, they could finally crack the code and make their own prediction for the current solar cycle 25. And let me tell you, the data backing them up was remarkably strong.
They went back and tested their discovery on all the historical data. The correlation was pretty good for one type of solar data, but for the raw sunspot numbers, that's what you see on the right, it was almost perfect. An R value of 0.96. I mean, in statistics, that is an incredibly strong link. That's what gave them the confidence to make a really bold new forecast.
So, what did the data predict? After all that work, after seeing the data in a whole new way, the network signal from the last solar minimum pointed to one specific number for the peak of this cycle: 179 solar cell readings. Now, let's put that number in perspective. The official solar cycle prediction panel predicted a relatively weak cycle, peaking at just 115 sunspots.
This new method predicts 179. That's a significantly stronger and more active cycle than what the official forecast told us to expect. And here's the kicker. This isn't just a theory anymore. The red line you see on this graph, that's their prediction. The jagged green line, that is the actual observed sunspot activity we've seen so far. Reality has been tracking their stronger forecast way more closely than the official weaker.
So, what does this all mean? Well, for one, it means we might be in for a more active sun than we were told to prepare for. But honestly, the story here is even bigger than just one solar cycle.
And that's really the crucial takeaway. This research has given us a powerful new tool. This whole method of turning a timeline into a network, it can be used to find hidden relationships in all kinds of complex data, from predicting earthquakes and financial markets to even being used in medical diagnostics.
And that just leaves us with this one fascinating final thought. This team found a powerful secret hidden in the sun's own data, not by collecting more information, but just by looking at what we already had from a different perspective. It really makes you wonder, right? What other profound discoveries are out there, not buried in new data, but just waiting for a new way for us to see them?